I want to show you a person who actually started classical physics. Maxim, is it possible to see my screen?
Yes, absolutely.
Okay. This great guy was called Zenon. And he formulated several problems about physics. There was no physics this day, but he formulated several problems about nature. And the first problem was the problem about an arrow. At time t1, arrow is here. At time t2, arrow is here. What is the meaning of moving arrow? If I just fix it like this, it would not move. However, it moves. So it was actually a Zenon problem. Now, it turns out that this Zenon, okay, let me speak a bit American English. I will call it Zenon puzzle. So it was solved completely only in quantum mechanics. That we will discuss next semester. So it was a equation of inertia of flying arrow. So the next attempt made Galileo. However, his attempt was not quite successful. And final attempt was made by Isaac Newton. So here we may see this man. He formulated the first law of mechanics. He said that inertia is a constant P of the body. You may ask what the body is. Just imagine a box, a brick. It is a body. And it moves like this with constant speed. And it was called inertia. In the same book, Newton said, the body could also rotate. And he also said that there is some kind of inertia in rotation. However, he did not formulate it. And you know why. If you have a body like this, if you rotate it and throw it this way, it would rotate with constant angular velocity. However, if you take a brick and you throw it, you will find an interesting phenomenon. It was not discussed in Newton's book. That angular velocity, so there are angles, there is a velocity. Velocity is the change, the speed, how body is rotating, is not constant. So Newton had a good idea, but it turns out that inertia is not conservation of the velocity. Okay? Later on, we will come to this. Okay? So the law of inertia is considered to be the first Newtonian law. But already at this moment, Newton forgot rotational degrees. Rotational coordinates. So Newtonian's law would be incomplete. Okay? Now, let us come to the so-called second law of Newton. So first law, incomplete. Then there is so-called second law. And second law was the following. Suppose that we have several bodies. My favorite brick, a ball, say a tetrahedron. Body 1, body 2, body 3. Then Newton said, bodies act on each other by forces. And each body has a quantity called mass. And Newton wrote the following. Equals to F to sum of for J non-equal to Y, Fij. And he said that this is a force with which body J acts on body I. So, keeping in mind that the first law is incomplete, we may assume that Ri should be something like position of center of mass. Here I have 0, here I have R1, here I have R2, and here I have R3. And you know what? It turns out that in real life, this law is wrong. Puzzle. Consider two bodies. One has mass m, capital. Another has mass m small.
Professor, I can't see the upper part of the blackboard.
Sorry, thank you. And we know that there is a gravitational force that Newton found. It is some constant times m over r squared. Now it is nice because if I cut this body into two pieces, I see that this is gm r squared m over 2 plus gm r squared m over 2. However, if we look at the sky, we see Mercury. That is rotating around Sun. So this is an ellipse. I exaggerated a bit. And then this ellipse is slightly rotating. And you can see it in the sky. And piece of this rotation comes from the fact that actual force has this g m times m over r squared plus g tilde m squared times m over r cubed. Now we have this non-linearity in mass. So what does it mean? It means that the force with which Sun is acting on Mercury is not a sum of forces produced by its components. Puzzle. So it clearly contradicts with the second law of Newton.
Andrey, sorry I missed. That's r cube. Is that an experimental observation? Where did it come from?
Yes, you may check it. It's not a theory. You may check it from experiment.
But where did it come from? Yeah, how did it appear for the first time ever? I didn't know, I have never seen this formula. Where did it come from? From some theory, from experience, where did it come from?
So this piece came as an effective theory from general relativity. But
okay. General relativity, the general relativity gives this contribution. Okay, yes. Thank you. Thanks.
But appearance of this contribution could be measured in how Mercury moves on the sky.
Understood. Thank you.
Now, here we see some kind of asymmetry. And with this asymmetry, we have to conclude that there is another term where masses are interchanged. Because the law should be universal. Sorry. And then it would mean that it is not true that acceleration maybe not acceleration, that the way how bodies fall does not depend on mass. So different body fall differently. You just put here something like M R two, sorry, not two dots. You divide by M, and you see that acceleration depends on M. So different bodies fall differently. And here we come to contradiction with another great man. Let me show you this great man, okay? Galileo Galilei, who said, who not only said, who made the first consideration in theoretical physics. He said, let us consider two bodies, M1 and M2, falling over the body with a mass M. And he said, let us assume, that's what Galileo said, that, say, behavior that if M2 is greater than M1, then body 2 falls faster. Okay? Then he said, assume. Then make a joint body, M1 plus M2. From the one hand side, it is even heavier. Okay. Has more mass. Than M2. So it should fall even faster. On the other side, he said, so M2 falls faster than M1. So body M1 keeps it back. However, body 1 pulls it back. So it should fall slower. Contradiction. Okay. So that's what I wrote here. So they should fall with the same acceleration. And this consideration is what known as mistakenly. It was mistakenly considered as Galileo derivation of equivalent principle. Okay, so we see that something is wrong in all this.
Andrey, what is the equivalence principle? Would you please remind?
Equivalence principle says that all bodies fall in gravity independently on their mass.
Okay, thank you. Mm-hmm.
And now let me come to so-called third Newton's law. So Newton formulated it as Fij equals to minus Fgi. And you may think, is it exactly what we need? So could we imagine a world where this happens, but that could not exist from our intuition? So let me make here what I called Newton's rotator. I have two bricks. And let me imagine that something that one force goes this way, another force goes this way. And let me connect them by a stick. Then I will get immediately perpetuum mobile. These things would rotate faster and faster. I call it Newton rotator. You see, I'm quoting books. I'm not quoting journalists. I am reading originals. Now, people are trying to correct it. And then they say that, okay, Fij could be proportional to what? It could not go like this. It should go like this. But how it should proportional? So first guess would be Ri minus Rj. But in real life, it's not like this. Suppose one body is the composition of two bodies. This is charged positively. This is neutral. So it is like proton, and this is like neutron. Okay, I'm starting to teach you something about elementary particle physics. And suppose here I have a proton. Then the direction of repulsion is like this. However, direction between center of masses is like this. So this is also wrong. You see, that's why when I was a schoolboy, I realized that I cannot read books on physics. So for normal mathematician, this is full of contradiction. So I just explained to you standard story from the high school program about Newton's law. So I hope that after me talking like this, you should understand that, I don't know, quality of your education, but most of high school education on physics is garbage. So mathematician could not tolerate it. Well, it is good to correct Newton, okay? So one has to step up and say, Newton had good ideas. However, these ideas have to be corrected. Now we will come to corrections. So ideas are great and they could be corrected, but the thing that you would need is the axiom number 0. There is an elementary body called material particle.
Excuse me, Professor, we couldn't
Yes?
see the upper part of the whiteboard. Thank you.
Sorry, thank you. Called material particle. So these material particles are completely described by their position. So they are not bodies. It's a new object. They are described by their radius vector. To ask what does it mean to rotate material particle has no meaning. And all bodies are made out of material particles. So then, the law number 1 about inertia makes sense. We should not talk about rotational inertia for material particles since this thing has no meaning, just because material particle doesn't have a rotation. Interesting thing is that elementary particles rotate in some sense, but the meaning of their rotation would be clear at the very end of my course. How electrode rotates. Or what is the spin? To understand it, you should know a lot. And I will provide you with this information.
Andrey, how does it work with the law? I know from school that the force is proportional to the mass, is proportional to the acceleration, and acceleration is more than the position of a particle. It's a position plus the acceleration, not just the position. It's some second derivative.
Acceleration is a second derivative. Acceleration is
the position as being a function of time.
Yes, of course. That's what I assumed. Maybe I forgot to say that position is a function of time. Otherwise, the very meaning of this
point in the space position.
So here we have a radius vector of the
Professor,
material.
your focus is not on the board. Focus.
So now I think focus is okay. Okay. You see, my camera is too smart. It wants to improve from time to time. And that's what it does. So this is called acceleration. So the zeroth law, the first law should be written like this. If there are no forces. Okay, Now inertia is clear. Let us try to correct the third law. Law 3, correct. Fij is actually parallel to Ri minus Rj. So it has meaning. For material particles. Okay? And now, let me come to the second law and its correction. The second law from this writes as follows. dri d2ri over dt squared is the gradient of ri of what? People put here minus sign. Of the function, sum of I and j going from 1 to n is the number of material points. And here we have u that depends on the moduli, on the modulus between Ri and Rj. And also on the type of this particle. So this is a gradient or partial derivative. Now, I can solve the problem with mercurium saying that Newton was a bit wrong, assuming that U could depend that U could depend only on 2 material points. Actually, this thing allows proper generalization. And here I write U that depends on R1, Rn, that is invariant under translations and rotations. Not necessarily pairwise. Not necessarily pairwise. This thing. Now you may ask, how does it happen that people formulated everything in terms of forces and kind of found no discrepancy for several hundred years? Basically, it's because U is not a fundamental concept. In quantum field theory, U is generated by fields. By field exchange. And field could be linear or nonlinear.
Andrei, what is a field exchange? Assume I know what a field is. What is a field exchange?
At the moment, it's a picture. And I will make it, now I will draw a picture. You are not assumed to understand it, but you may keep it in your mind. Because later on, I will explain this picture from the first principle. Okay, so here it is good to go to philosophy before Newton and Galileo. So before Newton and Galileo, people were thinking about ghosts. That there was body one, that it emits ghost. And this ghost goes to the body too. And instructs body too how to move. So this was so-called scholastic philosophy of the Middle Ages of Europe. And then Newton came and Galileo came, saying that there are no ghosts, that we do not need them. Later on, this idea that body produces something that acts the second body came back in the notion of the field. So let me tell you what you probably know from elementary physics. That you have a charge, and this charge creates electric field. And then this electric field is acting on another charge. So field somehow transmits forces. But electric field could exist alone without any charges. Like now we see radiation from the early ages of the universe called microwave radiation that comes to our detectors from all over of the universe. So field could exist without source. It is something that we know for sure. But in some approximation, you may think that you need source to create constant field. So the picture was like this. Body or the particle one, body or the particle two, and they are exchanging fields. And if they do it this way, then U would be sum over I non-equal to J, U, I, J, from these exchanges. However, it is interesting.
Did I understand correctly that the vertical coordinate here is time? You didn't specify, you didn't draw it.
Yes, yes. This is time. These are particles. These are fields. So fields are the modern incarnation of the Middle Ages idea of ghosts that you send, that are sent from one body to another body. Now, interesting thing can happen. Then these fields could be nonlinear, and graphically, it is something like this. So if they are nonlinear, we have the following interaction. Just imagine that first interaction is proportional to M1. And here we have something M2 and M2. So altogether, from this, we have potential that is proportional to M1, M2 squared. Or even better, suppose I have 3 elementary particles. And then I have such an exchange. Unfortunately, so these lines are not intersecting. So here I have such potential, IJK. And this is what was completely missed by Newton. So I will make a break. I just want to say the following. Here I see some cultural difference between East and West. And I assume that mentality of the West affected Galileo and Newton a bit. It is the idea of the force. So what is the force? Force is a kind of a violence. Subject 1 forces subject 2 to do something. That's what we call force in ordinary life. And people project this social practice to science. So force comes from violence.
Andrey, I couldn't see whatever you are writing. It sounds interesting, but I couldn't see it.
Okay. So force is about violence. However, if I have this UIJK collective potentials, it's about harmony. So this collective potential points of view is kind of, so this is a Western point of view. At least old Western point of view. And this harmony is Eastern. So you see, trying to be in harmony, where particles altogether are trying to minimize their potential, is a very Eastern idea, okay, from my point of view. So now we will do the following. And I hope I will do it all the time. I will make a 10 minutes break. Then I encourage you to ask questions, because I need to know you. So now you probably know me a bit, but I want to know you. So actually it's very important for the course. I need to know my audience. I can give lectures in many styles. So I'll try to adjust. So please, write me questions.
Yeah. Andrey, I would prefer to be able to see your face more of the time, because a lot of the time I could only see your glasses and your forehead, but not your smile and not your face. So if you can somehow be just camera. Yeah.
So we will start in exactly 10 minutes. Okay? And I will ask you to give questions again.